Installing HC Lincoln lights in a skylight requires careful planning and execution to ensure safety and compliance with electrical codes. Each can light is rated for 90 degrees Celsius and is not pre-wired. The question is how many junction boxes are needed, and is using THHN wire through a 3/8" whip acceptable. Only one junction box is needed for all HC Lincoln lights. A single junction box can accommodate multiple connections, making the installation more efficient and cost-effective than using multiple boxes. Using THHN wire through a 3/8" whip is acceptable for this installation. THHN wire is rated for temperatures up to 90 degrees Celsius, which meets the requirements of the CAN lights. The 3/8" whip will provide sufficient space for the wire and protect it from physical damage. Here are the step-by-step installation instructions. Firstly, prepare the junction box by installing a single junction box in the center of the skylight area. Secondly, run the whip from the box by running a 3/8" whip from the junction box to each CAN light location. Thirdly, connect the whips to the CAN lights by connecting the whips to the terminal blocks and inside each CAN light. Use wire nuts or other approved connectors to secure the connections. Fourthly, run THHN wire through the whips by pulling the THHN wires through the whips and into the junction box. Fifthly, connect the wires to the junction box by connecting the THHN wires to the supply wires in the junction box. Use wire nuts or other approved connectors to secure the connections. Sixthly, insulate and seal the junction box by covering the connections with electrical tape or wire nuts and sealing the junction box with an appropriate sealant. The electrical codes and regulations vary, so it is essential to consult local codes and obtain necessary permits before starting any electrical work. Always prioritize safety and consult a qualified electrician if needed. When working with electrical wiring, it is crucial to follow safety precautions to prevent electrical shock and ensure a safe installation. Before beginning any electrical work, turn off the power at the circuit breaker that supplies power to the lighting circuit. Double-check that the power is off by using a non-contact voltage tester to confirm that no voltage is present at the wiring. Wear appropriate personal protective equipment, including safety glasses and insulated gloves to protect against potential hazards. Use insulated tools that are specifically designed for electrical work. Avoid working in wet or damp conditions, as water can conduct electricity and increase the risk of electric shock. Never touch bare wires or electrical components with your bare hands. Always use wire connectors, such as wire nuts or terminal blocks, to make secure and insulated connections between wires. Properly ground all electrical components, including the junction box and CAN lights, to provide a path for fault current in case of a short circuit. Label all circuits and wiring clearly to prevent confusion during future maintenance or repairs. If you are unsure about any aspect of the electrical installation, consult a qualified electrician. Working with electricity can be dangerous, and it is always best to err on the side of caution. It is important to consider the National Electrical Code, or NEC, requirements for installing recessed lighting, including CAN lights. The NEC provides guidelines and regulations for electrical installations to ensure safety and prevent fire hazards. Some key NEC considerations for recessed lighting installations are as follows. Firstly, the NEC requires that recessed lighting fixtures be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all to ensure that they meet safety standards. Secondly, recessed lighting fixtures must be installed in accordance with the manufacturer's instructions and the NEC requirements. This includes proper spacing between fixtures, clearance from combustible materials, and secure mounting. Thirdly, recessed lighting fixtures that are installed in insulated ceilings or walls must be rated for insulation contact, or IC, to prevent overheating and fire hazards. IC-rated fixtures are designed to dissipate heat safely when in contact with insulation. Fourthly, recessed lighting fixtures must be properly grounded to provide a path for fault current in case of a short circuit. Grounding helps to prevent electrical shock and minimize the risk of fire. Fifthly, the NEC specifies the type and size of wiring that is allowed for recessed lighting installations. Typically, THHN or THWN wire is used for branch circuit wiring, and the wire size must be appropriate for the circuit amperage rating. Sixthly, junction boxes must be used to make electrical connections for recessed lighting fixtures. The junction boxes must be accessible and comply with NEC requirements for size, till capacity, and enclosure type. Seventhly, recessed lighting fixtures must be installed with adequate clearance from combustible materials such as wood framing and insulation. The NEC specifies minimum clearance distances to prevent overheating and fire hazards. Eighthly, recessed lighting fixtures must be protected by overcurrent protection devices such as circuit breakers or fuses to prevent damage from excessive current flow. The overcurrent protection device must be rated appropriately for the circuit amperage rating and the fixture's power consumption. Ninthly, recessed lighting installations must comply with local building codes and regulations, which may impose additional requirements beyond those specified in the NEC. Tenthly, it is essential to obtain the necessary permits and inspections for recessed lighting installations to ensure compliance with local regulations and safety standards. Consulting with a qualified electrician is recommended to ensure that recessed lighting installations comply with all applicable codes and regulations. A qualified electrician can assess the specific requirements of the installation, provide guidance on proper wiring and fixture selection, and ensure that the installation is performed safely and in accordance with best practices. Proper planning and attention to detail are essential for a successful recessed lighting installation that meets safety standards and provides reliable performance. Here is a more detailed look into the step-by-step installation process. Firstly, preparing the junction box. Choose a junction box that is appropriately sized for the number of wires and connections that will be made inside. The junction box should be made of metal or plastic and must be listed by a recognized testing laboratory. Mount the junction box securely in the center of the skylight area using screws or other appropriate fasteners. Ensure that the junction box is accessible for future maintenance or repairs. Secondly, running the whip from the box. Use a 3/8-inch flexible metal conduit or whip to connect the junction box to each conlight location. The whip should be long enough to reach the conlight location without being stretched or strained. Secure the whip to the junction box and the conlight using appropriate connectors such as conduit fittings or cable clamps. Thirdly, connecting the whips to the conlights. Remove the cover from the conlight's wiring compartment to access the terminal blocks inside. Connect the wires from the whip to the terminal blocks, matching the colors of the wires to ensure proper polarity. Use wire nuts or other approved connectors to secure the connections and ensure that they are tight and insulated. Fourthly, running THHN wire through the whips. Cut lengths of THHN wire that are long enough to reach from the junction box to the conlight with some extra slack for making connections. Use a wire stripper to remove the insulation from the ends of the wires, being careful not to nick or damage the conductors. Push the THHN wires through the whip, starting from the junction box end and working towards the conlight end. Fifthly, connecting the wires to the junction box. Remove the cover from the junction box to access the supply wires inside. Connect the THHN wires to the supply wires, matching the colors of the wires to ensure proper polarity. Use wire nuts or other approved connectors to secure the connections and ensure that they are tight and insulated. Sixthly, insulating and sealing the junction box. Wrap electrical tape around all wire connections inside the junction box to provide additional insulation and protection. Use a silicone-based sealant or caulk to seal any openings or gaps in the junction box, preventing moisture and dust from entering. Replace the cover on the junction box and tighten the screws to secure it in place. After completing the installation, test the conlights to ensure that they are working properly. Turn on the circuit breaker and switch on the lights. Check for any flickering, dimming, or other abnormalities. If any issues are detected, turn off the power immediately and investigate the problem. If necessary, consult a qualified electrician for assistance. When selecting THHN wire for the conlight installation, it is important to choose the correct wire gauge to ensure that it can safely handle the amperage load of the lights. The wire gauge is determined by the size of the wire's conductor, which is measured in American wire gauge, or AUG. The lower the AWG number, the larger the conductor and the higher the amperage it can safely carry. The NEC provides guidelines for selecting the appropriate wire gauge based on the circuit amperage rating. For example, for a 15 amp circuit, number 14 AWG copper wire is typically used, while for a 20 amp circuit, number 12 AWG copper wire is required. To determine the appropriate wire gauge for the can light installation, calculate the total amperage load of all 8 can lights. Add up the wattage of each can light and divide by the voltage of the circuit, which is typically 120 volts in residential applications. The result will be the total amperage load of the lights. Once the total amperage load is known, consult the NEC tables to determine the appropriate wire gauge for the circuit. It is always best to err on the side of caution and choose a wire gauge that is slightly larger than what is required to ensure that it can safely handle the amperage load. In addition to wire gauge, it is also important to consider the ampacity of the THHN wire. Ampacity is the maximum amount of current that a wire can safely carry without overheating. The ampacity of THHN wire is determined by its insulation type and the ambient temperature in which it is installed. The NEC provides tables that list the ampacity of THHN wire for various insulation types and temperature ratings. When selecting THHN wire for the can light installation, choose a wire with an ampacity that is equal to or greater than the circuit amperage rating. This will ensure that the wire can safely carry the current without overheating or posing a fire hazard. It is also important to consider the dating factors that may apply to the ampacity of the THHN wire. Dating factors are adjustments that must be made to the ampacity of a wire when it is installed in certain conditions, such as in conduit with other wires or in high ambient temperatures. The NEC provides guidelines for calculating dating factors based on the specific installation conditions. When calculating the appropriate wire gauge and ampacity for the can light installation, it is important to consult the NEC tables and guidelines and to consider all applicable dating factors. It is also recommended to consult with a qualified electrician to ensure that the wire selection is appropriate for the specific application. When installing the can lights in the skylight, it is important to ensure that they are properly sealed to prevent moisture from entering the fixture and causing damage or electrical hazards. Skylights are exposed to the elements, including rain, snow, and condensation, which can seep into the can lights if they are not properly sealed. To seal the can lights, use a silicone-based sealant or caulk to seal any gaps or openings around the fixture. Apply the sealant to the perimeter of the can light to where it meets the skylight, as well as to any other areas where moisture could potentially enter. Ensure that the sealant is compatible with the materials of the can light and the skylight to prevent any adverse reactions. In addition to sealing the can lights, it is also important to ensure that the skylight itself is properly sealed to prevent water leaks. Check the skylight for any cracks, gaps, or damaged seals and repair them as needed. Apply a sealant to any areas where water could potentially enter, such as around the edges of the skylight and where it meets the roof. Regular maintenance and inspection of the can lights and the skylight can help to prevent moisture problems and ensure that the electrical system remains safe and reliable. Check the fixtures and seals periodically for any signs of damage or deterioration and make repairs as needed. Clean the skylight regularly to remove any dirt, debris, or algae that could obstruct the passage of light and contribute to moisture buildup. By taking these precautions, you can help to prevent moisture problems and ensure that the can lights in the skylight provide reliable and safe lighting for years to come. Here are some additional tips for installing can lights safely and effectively. Firstly, plan the layout of the can lights carefully to ensure that they provide adequate lighting coverage and create the desired ambience. Consider the size and shape of the room, the location of furniture and other fixtures, and the amount of natural light that is available. Secondly, choose can lights that are appropriate for the intended use and location. Select fixtures that are rated for the correct voltage and wattage and that are suitable for installation in a skylight environment. Thirdly, use a stud finder to locate the ceiling joists before cutting any holes for the can lights. Avoid cutting into the joists, as this could compromise the structural integrity of the ceiling. Fourthly, use a hole saw to cut the holes for the can lights, ensuring that the holes are the correct size and shape for the fixtures. Be careful not to damage any wiring or other components that may be located in the ceiling. Fifthly, install the can lights according to the manufacturer's instructions, ensuring that they are properly secured and wired. Use wire connectors to make secure and insulated connections and double-check that all wires are properly grounded. Sixthly, test the can lights after installation to ensure that they are working properly and that there are no electrical hazards. Turn on the circuit breaker and switch on the lights. Check for any flickering, dimming, or other abnormalities. Seventhly, label the circuit breaker that controls the can lights to make it easy to identify and turn off the power in the future. Use a permanent marker or label maker to create a clear and durable label. Eighthly, keep the area around the can lights clean and free of clutter to prevent fire hazards and ensure proper ventilation. Do not store any flammable materials near the fixtures. Ninthly, inspect the can lights periodically for any signs of damage or wear and tear. Check the wiring, connections, and fixtures for any loose or corroded components and make repairs as needed. Tenthly, if you are not comfortable performing the electrical work yourself, hire a qualified electrician to install the can lights. An electrician can ensure that the installation is done safely and correctly and that it complies with all applicable codes and regulations. By following these tips, you can install can lights safely and effectively and enjoy the benefits of improved lighting in your home.